Hey guys, I just was getting tired, so I went to Starbucks and I was like, "Can I just get a coffee?" They put all this crud in their coffee there. I mean, I know a lot of people like it, but there's all the sugars and creams and stuff like that. And I said, "Can I just get a coffee with no cream?" And she said, "I'm sorry, sir, we're out of cream. Would you like your coffee without milk instead?" Like, yes. Let's talk about strong and weak bases, shall we? Strong and weak bases. So strong and weak acids and bases. And we're going to talk about acid-base reactions here. All right, so I know it's a bad joke, guys. Give me a break. I'm just trying to do something. I get bored doing this too. All right. So strong acids. We've got a definition of a strong acid is something that completely ionizes in water. So strong acids completely ionize in water. Hydrochloric acid is an example of a strong acid because when hydrochloric acid is placed in water, if you have gas, you run hydrochloric gas through water, it will dissociate into hydrogen ions and chloride ions completely. So what's unique, or what you should notice about strong acids, is that a strong acid has a one direction arrow. This is not bidirectional. So this will convert completely into your strong acids. It'll completely ionize. Whereas a weak acid, weak acids do not ionize completely. So here's an example of formic acid, which is the formate ion. There's hydrogen here. Remember, we don't say hydro if we have a polyatomic, so this is just formic acid. And when formic acid is in water, it will dissociate into the hydrogen ions and the formate ion, but these guys can react with each other back to make formic acid. And so you're going to have this constant back and forth going on until you reach your equilibrium. By the way, since this is an acid and we have talked about equilibrium before, this would be based off of your Ka, the equilibrium constant for an acid. The greater the Ka value, and just pay attention here, the greater the Ka value, that would mean the more product you have, because remember, it's products divided by reactants. So the greater the Ka, the more hydrogen would be released. Blah, blah, blah. So it would be more acidic. Okay? But weak acids they're not completely dissociating, so you're not going to get as much hydrogen ion out of a weak acid as you are out of a strong acid, because the strong acids completely ionize. All right, strong bases, just like strong acids. Strong bases completely ionize, so sodium hydroxide. If you put sodium hydroxide solid, which is normally found in a solid, and you put that in water, it will completely ionize into the sodium ions and the hydroxide ions. There is no equilibrium. It will not associate back and form this solid. So that is the definition of a strong base. It's just like a strong acid. It completely dissociates, and you'll have one-way arrow here, where a weak base will have a double arrow. And I have a good example of a weak base here, in that we get so used to seeing hydroxide, and hydroxide is base, hydrogen is acid. Well, ammonia is a base. If we take a look at ammonia right here, is NH3, and you notice there's no hydroxide here. And the definition of a base is something that produces hydroxide. So how does ammonia produce hydroxide? Well, what it does is it reacts with the water. And what happens is the water molecule loses one hydrogen to add to the ammonia to make it ammonium. And what gets left over is hydroxide. So one hydrogen atom from water moves over here. And so you get the extra hydrogen ion and the extra charge. And that leaves water as the hydroxide. So it's a little bit tricky here. And then this can associate back together to make ammonia. Now ammonia can be dissolved in water, but it can also be gaseous, so this can float around, and that's why if someone's been cleaning with ammonia, it burns your nose, it burns your eyes if you go into a room that's been recently cleaned with ammonia, and that's because this NH3 is floating around in the room, and then if there's some water, some moisture in your nose and your eyes, if there's water in your eyes, then this reaction actually happens right on your eyes, and that's why your eyes burn in the presence of ammonia, because in the presence of, so this is floating around the room, the water on your eyes causes this equilibrium to happen. It creates ammonium hydroxide in your eyes, and hydroxide is corrosive, and that's why your eyes are burning. And so your eyes will start watering trying to flush that ammonia out of your eyes trying to dilute it. But unfortunately, if you don't leave the room, then you're just going to have more reaction happening on your eyes. So you got to get out of there. All right, let's talk about some neutralization reactions here. So we've got an acid and a base here. We've got hydrochloric acid reacting with sodium hydroxide. What happens when you put an acid and a base together? Well, the acid and the base will both dissociate in water. So the hydrogen chloride becomes a hydrogen and a chloride in water, and the sodium hydroxide becomes sodium and hydroxide in water. But what will happen here is, remember, there's something called a Kw. And again, this is referring back to our equilibrium. The Kw is the equilibrium of water and how water dissociates into hydrogen ions and hydroxide ions. Back over here, producing the hydrogen and the hydroxide will form water. And then what you have left over is a salt. And the salt is determined by what kind of acid and what kind of a base you have. The anion is going to be based on the acid, and the cation is going to be based on the base. So the sodium is the base, sodium hydroxide, and the chloride is from the acid because it was hydrochloric acid. So when you have neutralization reactions, you're always going to produce a water and a salt. So it just depends on which acid and which base you're using to determine what that salt is, but you're going to get water when it neutralizes. This is basically a double displacement reaction. We've done this when we talked about types of reactions. A double displacement reaction, you just take the cations and switch them. So take the Na over here, so it's NaCl, and take the H over here, so it's HOH. HOH is H2O, is water. So just switch these two, and that's how you do that. So there's some misconceptions I want to go over, and I'm just going over this because asking questions over the years with chemistry, there's just these questions are missed so often. I'm just telling you, I ask questions to see if people understand the concepts, and and these things are just missed so often. I'm just going to tell you the answers straight up on what the most common misconceptions are with acids and bases. And the first one is, the strength of an acid depends on the number of hydrogen ions that are produced in solution, not the number of hydrogen ions that the acid contains. And so a lot of times people will think, what I mean by this is people will think that that's what I mean by this one here. Another misconception is that people think, and I'm just saying this because I see it so often wrong on tests, people think that acids are stronger than bases. But that's not true. A strong base is just as reactive as a strong acid. And I say this in class that I think it just has a lot to do with pop culture, that we always talk about acids, and we do have acids in TV shows and cartoons and all kinds of stuff like that, and we don't really talk about bases. It's just not, I don't know, it doesn't roll off the tongue so well. Base. It's not scary. Acid's scary. So, but bases are just as reactive. I certainly wouldn't want to get a chemical burn with bases. Definitely not. They're just as reactive. So common misconception, but it won't be for you because you're watching, you're paying attention, you're on this. So here's our workshop. Just a real simple one here. I want to see if you can predict what will be the product here. So what can you predict? I'd like you to pause this and try right now, and then I'm going to go and show you. But please give it a try on your own first. Okay, hopefully you did. Let's take a look at what the answers are.